All right, here in the first problem, first we have to define our system. So the cart and spring are the system. We write that in the O. Then we look at our situation here. The car is not moving, the spring is compressed, and then at the end it looks like the spring uncompressed and launched the car. It says V greater than 0, so it's moving. So if we want to fill in the first L, our energy at the beginning, we go through our questions. Is anything moving? Nope, so no kinetic energy. Is anything changing heights? Nope, no gravitational energy. Is there a spring involved? Yes, and it is compressed right here, so that's why we have spring energy. Are there any chemicals involved or anything burning? Nope, so no chemical energy. So just all spring energy at the start. At the end, we have our spring sprung, so it has launched the car to the right. The car is now moving. So yes, we have kinetic energy. No height change, so no gravitational energy. The spring is not compressed anymore, so no more spring energy, and still no chemical energy. Then our energy equation for this one is just simply E spring equals EK. So we just have the spring energy at the start becoming kinetic energy at the end. In our second problem, we have the block and spring as the system. So there we go, right block and spring. Then we look, our spring is compressed here. It says the block isn't moving and it's on the ground. So we say isn't moving, no kinetic energy, on the ground, no gravitational energy, spring is compressed, so all spring energy. And again, no chemicals here, so no chemical energy. When we look at the end, we see our block is moving, it's up in the air, the spring has launched it up there, so the spring has given up its energy, and now since the block is both moving and up in the air, it gets some kinetic and some gravitational energy. We don't know for sure that it's 2 bars and 2 bars. We don't know for sure that they're even. It could be like 3 kinetic and 1 gravitational, or 1 kinetic and 3 gravitational. Just as long as our kinetic plus our gravitational adds up to how much spring energy we had at the start, that's all we need. And then our energy equation here, we have spring energy becoming a combination of kinetic and gravitational energy. In the third one, we have the cart as the system, so we just write that in our O. The cart is moving up the hill. It is moving at the start and at the bottom of the hill, so moving kinetic energy. Bottom of the hill, we define that as our lowest point, so we say no gravitational energy. No springs, no chemicals, so we don't have to worry about those. At the end, since the car is going uphill, it is going to roll to a stop. So since it's stopped, no more kinetic energy, and now it's up higher in the air, so it has gravitational energy. And then our energy equation is just kinetic energy equals gravitational energy. On to number 4. Number 4 and 5 kind of go together, so we'll look at number 4 first. The cart and spring are our system, so we write that in the O. Then our spring here is compressed, so we're going to have some spring energy. Car's not moving yet, not changing height, or it's not off the ground at the beginning, so that's why no kinetic and no gravitational at the start, just all spring energy. Then at the end, as it goes around the loop, it is moving and it's up in the air, so we're just going to give it 2 and 2. Doesn't need to be 2 and 2. That just makes it easier for when we look ahead at number 5. Our energy equation here, we have spring energy becoming kinetic energy and gravitational energy. Now in number 5, same starting as number 4, so same starting situation, so just spring energy, same system, cart and spring, but now at the end, the car isn't as high up the loop, so whatever we did in number 4, we gave it 2 bars of energy here, it needs to have less gravitational energy because it's not as high in the air, so just less gravitational energy. And because of that, because of the first law of thermodynamics, we need to have the same energy at the end that we do at the start. So if we have less gravitational energy, that must mean we need more kinetic energy. So that's why kinetic energy is a little higher. And then we can also use that to tell it's going to be going faster right here than it would be at the top of the loop. Energy equation for that one, spring energy just becomes kinetic energy and gravitational energy. In number 6, we have the spring compressed, car not moving, down on the ground. So we have spring energy for the compressed spring, on the ground, so no gravitational energy, not moving, no kinetic energy, still no chemicals. Then at the end, we launch this car forward. It's up on top of the hill now, and it's moving. So on top of the hill gets us gravitational energy, moving gets us kinetic energy. The spring has used up its energy, or it has transferred its energy to the car, so no more spring energy. And then our energy equation for this one, spring energy just becomes a combination of kinetic energy and gravitational energy. Last one, this time it says a car with a gas tank as the system. So that is a good hint to us that we're probably going to need chemical energy. And it says the car speeds up from rest. So that means it's not moving at the start, so it has no kinetic energy. We're not changing our height here, so no gravitational energy, no springs involved, so no spring energy. And then this one, it says right here, gas tank, so we're going to need some chemical energy. The car is going to use some of its gas to actually start moving. At the end, the car is moving, so it gains some kinetic energy. We don't know how long the car has been moving. We don't know how much gas is left in the tank. So when we did this answer key, we just said half of the gas is left in the tank, so that's why it is half as much chemical energy at the end. And all of that energy just got used to make the car move. So then we have kinetic energy. Notice again, first law of thermodynamics, kinetic energy plus chemical energy, 2 and 2, add up to our starting energy of 4. Our energy equation for this one, chemical energy equals kinetic energy plus what's left of the chemical energy.